Cisco instructor Andrea here. This video is going to talk about how to configure extended IPv4 access control lists. In a previous video we did standard access control list, and there's several similarities. However, if you remember, with an extended access control list, we've got some ability to do some fine tuning. With access control lists that are extended, we can filter based on the destination address, whereas if you remember with a standard, we could only do it based on the source. So extended, we can look at destinations. We can also look at the specific transport protocol, like is it all of IP? So if we were to filter for IP, that would mean all TCP, UDP, ICMP traffic, or I could fine tune it down even smaller to be just TCP traffic, just UDP traffic, ICMP. We can also add a port number in there so that we know what ports the traffic will be allowed to access or denied from. Just like the standard access control list, we can do a number extended access control list or a named extended access control list. The way that we write the access control list varies a little bit. Remember, with a numbered, all we need is access list followed by the number. And with the named, we need to start it with IP access list and include the word extended here, and then we name it. Just like a standard access control list, I do prefer the named a little bit more because that allows me to be a little descriptive within the name of what my filter is going to be doing. Let's do a quick review. Which one of these numbers could be used to create an extended IP access control list? Okay, so you should pick out 142. Also, we would pick out 2,496 and 199. Why? If you remember, standard access control list and extended access control list have specific numbers that have been assigned to them to be able to create these. 1 to 99 and 1300 to 1999 are reserved for standard access control list. And then the extended, these are the numbers reserved for extended, 100 to 199 and 2000 to 2699. This is actually a really common question on the CCNA exam. They'll give you a standard access control list, or actually more likely they'll give you an extended access control list. That's a numbered access control list, and it will be like access list 2, and then it will proceed to give all of the parameters just like an extended access control list. And it says, why doesn't this work? Well, the reason it doesn't work is because the number 2 does not allow for an extended access list, so the parameters that are assigned won't work. All right, with an extended access control list, there again is that fine tuning. So I want to kind of prep this by the best way to create an extended access control list is to start with all of the possible information that you know. Extended access control lists allow us to deny or permit traffic just like anything else. We can determine the traffic type. Also, we can still filter by source just like a standard. So you might want to gather the source information. We can also filter based on destination and whatever our protocol and port number is. So let's just walk through this. Again, I want to help you understand the more information you can gather, and then you also want to have a topology, the easier it will be to write the access control list. So we can do a numbered or a named. We can deny or permit. Now, transport traffic would be like, is this IP, TCP, UDP? We can even narrow it down, RIP, EIGRP. What type of traffic are we wanting to filter? Now, if you want to you don't want to make it too finite, really. You don't want to limit it too much, then do IP. Make it just IP. That will allow TCP and UDP. So with our source network, we could still use the keyword any. Okay, so like anything that's coming through. We could use the keyword host if we're just attempting to filter based on a host, or we can use the entire network. The source wildcard, again, we can be any. We can use the network address plus the wildcard of any. So then it will let any of the hosts come through. We can also use the specific wildcard mask. Destination, okay? I can use the keyword any for my destination, keyword host if I'm trying to filter with a specific destination host in mind, which would be common. Let's say I set up an HTTP server and I want to be able to filter based on that host's IP address of that web server. Or I could use the entire network. Destination, I could use any or the wildcard mask. All right, so now with the protocol and the port type, we're gathering this information up because we're going to write the access control list. So what we need to think about in this scenario is, what is the traffic type? As an example, if I'm going to do a filter based on HTTP traffic or 80, port 80, do I want to filter the TCP traffic? Do I want to filter the IP, let all of it IP? Okay, so these two kind of go together, all right? HTTPS. So if you remember HTTP and HTTPS, they're TCP because they have to establish a connection. SSH, port 22, same thing. That's TCP traffic because SSH has to create a TCP connection. Telnet, TCP. Okay, so it will be TCP traffic. If I don't want to make it so granular, I could back it off and use IP. And then over here, established, we're going to actually talk about that maybe in a different video or at the end of this one. So the answer is either yes or no. The short summary of what established is if I make a access control list to filter traffic that's going to be leaving my private network, going out, say, to the cloud, do I want traffic to be able to come back? And if I do, then I need to add an established access control list. Otherwise, that traffic, when I make a connection, like if I'm trying to get information off of Google and I want them to be able to send the information back to me, if I haven't established that connection and allowed the answer to come back to me, it might not be able to. Lastly, we want to think about, well, where am I going to be putting this access control list? So if you remember, typically an extended access control list will go as close to the source as possible. Doesn't always make sense, but in most cases it does. So what kind of information do we need? My best advice, again, is be looking at a topology when you're going to be creating these access control lists. So in this example, let's say R1, and I'm going to put that on G01, and I want the traffic to get looked at on the way out. So this is the order in which you will write the access control list. Think of it in terms of how it's getting processed, how it's being looked at as the packets are flowing through the network. What we had said is that we can filter based on protocols and ports. So here's an example. The question mark really comes in handy when writing extended access control lists. So here we're doing access list 100, again 100 because it's extended. We're going to do a permit statement. Now I can do a question mark and it will show me all of the different protocols that I can enter into an access list. They're highlighting the most popular: ICMP, IP, TCP, UDP, the ones that we talked about. And then if we use the question mark again, so here, if we compare that to what we just laid out to selecting the protocol, we are doing 100, we're permitting TCP traffic from any source to any network, right? Destination that is equal to, and so now we're going to be looking at what the port numbers are. So we're going to use a question mark. Now you can also use the keyword FTP or the keyword POP3 or Telnet or www. So it will take either, the command line will take either the port number or the specific protocol. I'm going to show you an example here in a minute, and we'll use packet tracer. I don't have a fully functional packet tracer with every type of server on it. However, we'll get the general idea. And there are some limits to packet tracer. All right, so here is an example. Access list 100. We're permitting TCP traffic, okay? Because the www, that is HTTP. So it's got to establish a connection. So it's TCP traffic. So again, any network, any destination that is equal to www, that's HTTP. Or I can write it using the port number 80. Here's another example. Access list 100. We're permitting TCP traffic, any network, any destination that's equal to 22. So this is permitting anything for port 22. So we're allowing SSH. And here is our 443 for our HTTPS. And then this last step is we are applying it to the interface, because if you remember, access control lists don't do anything until they're actually applied to the interface. So you may have written these access control lists, wonder, well, why isn't it working? working, go back and see if you actually connected it and configured it on the interface. Let's go ahead and talk about the established keyword right now. This is an example talking about how you can use TCP to function like a stateful firewall using the established keyword. So the established keyword enables inside traffic to exit the inside private network, right? So we're familiar with that. Here's our private network. It's a 192 address. So we know that's a private address, just like if we had a 10 address or a 172, and permits returning reply traffic to enter the inside private network. So in this situation, if I put a filter on here, I put an access control list filter on here, and I send a request out onto the public network, well, the internet or the public network is going to want to send an answer back. But because of the implicit deny, it may not be able to do that. So what we need to do is we need to make sure that whatever is generated from inside the network going out, we allow traffic to come back and have that reply answer. That is what using the established command will do. Essentially, it's saying, hey, if I've already established this TCP connection in order to request and get information from the outside world, let the outside world respond to me. Now, if some actor is out here, right, some person is out here and they just want to contact you, they just want to get to PC1, and they send a ping, they send a request, anything, it will not, because if it originates here, it will block that traffic. It will filter that traffic. It will only allow traffic from the internet if it was an established TCP connection and you've got the access control list set up that way. I'm going to walk through a detailed example of the established access control list. I think that will make more sense. So here we have our private LAN network, just like in our previous example, and out here we have our public internet network. So if our security policy is to permit LAN 1 to connect to the internet using HTTP or HTTPS, how would we write our access control list? So this will also be a good demonstration of that. Let's do a numbered access control list, and we're going to call it numbered 110. And we're permitting, so we're going to permit. And what type of traffic is HTTP and HTTPS? It's TCP traffic. My source networks, we want to allow all hosts from here. So my source will be 192.168.10.0. My wildcard mask is 0.0.0.255. Another way we could have written that is using the keyword any. If there were no other networks, and this was the absolute only network, and we want to allow all of that network and all of that host, we could have used the keyword any. Where does this LAN need to go? Where do I want to permit it to go? Well, we're going to permit it to go to any location on the public network out towards the internet. So here we're going to use the destination any. Now, because I'm using any, I don't need to include a separate wildcard mask. The any is implied here. What protocol and or port? So it's www for regular HTTP traffic, or we can use port 80. Now over here we want to ask ourselves a question. Is the type of traffic that is being filtered, is that going to give us a reply? Is that going to be sending something back to the originator? In this case, the answer is yes, it is. So we just are going to put a yes right here to remind us that we need to create the established access control list. Okay. So remember, our policy was for HTTP and HTTPS, so we're going to write another entry. Okay, it's the same access control list, so it's still 110. It's just another entry. Permit TCP, same source, same wildcard mask. We're going to be allowing it to go out to any destination. And now we're doing it for 443, okay, or HTTPS. There isn't a way in the command line to do anything other than 443. Do we want to allow established traffic to return? Yes, we do. Next, what do we have to think about? We have to think about what interface are we going to put this on. We're doing an extended access control list. The rule of thumb is to put it as close to the source as possible. So what that means is we're going to be putting it on G00. So what device? R1. What interface? G000. What access control list are we binding it to? 110. And when or what are we doing this? Are we looking, do we want the packet looked at on the way in or on the way out? Well, it's going to be on the way in because we're sending the packet from PC1 into the router. Okay, so it's in. So here's how it would look. We'd have our access control list written, and the any is for the destination equal to www. We could also have put port 80 in there. Here's us adding it onto the interface, IP access group 110 in. So remember, this is binding this access control list to this interface. Does that all make sense? So now we're letting the traffic out, but how does the reply come back to the host who made the GET request? We've let the traffic from LAN A get out to the internet, out HTTP. So now what we need to do is figure out how to let it come back. So here's what we've already done. Right, we've already done this part. We've set up our access list 110. So as part of our security policy, we want to permit returning traffic. So I've made a request. I want to let that come back. We need to set up another access control list. This can be a little confusing because we're actually creating a new access control list. Because if you think about the parameters of setting up control lists, it's like you can only allow so many on an interface going in, so many interface going out, and this traffic is going to be coming from a different direction. Initially, the traffic was going this way. Now the traffic is going to be coming into our network, so we have to think about it in terms of that. Okay, so here's how we would write this. We're going to do a new numbered extended access control list. We're going to call it 120. We are permitting the traffic. It's TCP traffic because we've established a connection with a session. Now the source. This time, this is our source, right? So we're going to allow any network source. So that's why we're using the keyword any. I don't need to put a wildcard mask because the keyword any covers that. What is the destination? The destination is now our private LAN network, 192.168.10.0. We want to let it go to any of the hosts. Now, what are we doing? We've already talked about, and our first access control list established that it's 80 and 443. So we're just going to say if there is an established TCP connection, if the traffic is as a result of an established connection, let it come in. So it's established. Here's what our command is going to look like. TCP any 192.168.10.0 000.255. Established. Now we need to apply the new access control list onto an interface. The rule still applies. We want to put it as close to the source as possible, right? So here was what our original generator was. So we're still going to put it on G000. Now the traffic is going to come into G001, and then when will it be looked at? Well, it's going to be looked at when it is going out G00. Okay, so this new access control list 120 will be looked at on its way out of that interface. So that is why we have IP access group 120 out. Let's use a few of our show commands to take a look at what's happening here. Here were our original access control lists allowing web traffic out. Here's our new access control list allowing a reply, a response. So if we did a show access list, it's going to show us what we're permitting. Now in this case, you can see what's being generated is HTTPS traffic, right? So this PC1 is using HTTPS. We've had 657 matches, and when we're coming back, we've had 1,166 matches for responses. This does a nice job of explaining why that's happening, right? A match occurs if the returning TCP segment has the acknowledgement, the ACK, or the reset the flag, indicating that the packet belongs to an existing TCP connection that's already been made. I hope that helps explain the established command a little bit better. I'm going to do a demonstration in Packet Tracer of how to do an access control list, and we'll do a named access control list since the last example we did was numbered. So I'm going to do a named, and here's my security policy. I want to permit this host, PC4, to have HTTP access and ping access to a specific host, which is this guy over here. So this PC is going to have ping access and HTTP access. So since I'm doing a named, let's name it PC4 permit. We're doing a permit. And since it's HTTP, let's work on the HTTP first. That is TCP traffic. And we're going to use the keyword host. And it's a specific device, so 192.168.30.12. Because it's a specific host, I don't need to use the source wildcard mask. Also, I'm going to be permitting it just to a specific device, the web server. So again, I'm going to use the keyword host here and 192.168.31.12. Again, I don't use the wildcard mask because it is a host. What protocol? Let's just go ahead and do equal to 80. In this case, it's not established because I'm not going out to the cloud or an internet. This is still network that I have control over. Now we also need to do the access control entry for the ping. So my name, it still is the PC4 permit. I'm permitting, permit. This is ICMP traffic from host 192.168.30.12 to host 192.168.31.12. And I actually don't have to put anything here for ICMP. I'll just leave it like this. Okay, so now let's see, what do I want to do next? Let's take a look at my topology. I know I've said this before, but if you have a topology, it will help you write these. So what device am I going to put this on? I'm going to put it on R3. Okay, and let's see here. What interface is it going to go on? Well, if we put it to the closest one, that will be G00. And I'm going to have the access control list looked at on the way in. So it's going to be in. I've gathered all the information I need. Now I can write the access control list. So I'm going to be writing it on R3. So let's actually first do a show run pipe section access list. Make sure nothing is there. And there's nothing there, so I'll go into global mode, IP access list. I'm writing an extended access list, so I'm going to tell it that PC4 permit. So there we've got it, and it's put me into access control list mode. So the first thing I'm going to do is permit. I could have written this in a text editor and just copied and pasted it. That would work really well too. 12 host .12 equal to 80. Perfect. Now, I didn't put a remark. Let's put a remark in there. So, permitting host 192.168.30.12 HTTP and ICMP access to host. Just giving it everything it needs. So there's my remark. Now let's get our other permit statement in here. Permit ICMP host. All right, now my destination. Now I can do the question mark to see what I need to put in here. And I can just hit enter, or I could do echo, but let's just hit the enter in this case. And I like to include the implicit deny in here so that we can see it in the counter. So we're saying deny IP, any source, any destination. Let's take a look, show run. Section access list. All right, there we've got it. And let's just do a show access list. Looks good. Permit TCP host, permit ICMP host, and then deny everything else. Will it work? It's not going to work yet because we have not added it to the interface. So let's go ahead and add it to the interface. IP access group, all right, PC4 permit, and what direction is it going, right? We're going to look at it on the way in. Okay, now we want to see what happens. So what should happen is this PC should be able to hit the web browser. So let's find out. So here's my web browser information, 92.168.31.12. Aha! We reached the website of Bugs Bytes, right? Welcome to Bugs Bytes, where your bytes are safe. Check message, click here. Hello, how much does a woodchuck chuck? So we're making it. Now what about PC5? Will it make it for web traffic? We're going to check it. We're going to see if it can hit this HTTP server. What do you think the answer is? Should it be able to get there? No, it should be blocked. And it is blocked. Perfect. So far, everything's working the way we want. Now let's try ping traffic. Okay, so ping 192.168.31.12. That works. Now what if I ping from here, my PC4, up to my DNS server? Do you think that will work? It shouldn't, because we specifically allowed ICMP traffic from a particular host to a particular host. So it should fail because of the implicit deny, and it is failing. Same goes with this one. This one should fail because the implicit deny. So we're pinging the .12 address up here. It's failing. And if I ping the DNS server, it should fail as well. Failed. So that worked. Now let's assume I wanted to change the access control list policy. So instead of permitting the ping just from 192.168.30.12 to just 192.168.31.12, let's say I wanted to allow all pings. So there's a couple of ways that I could do that. I'm going to show you the way that I think might be easiest. So if I show access list, right, here I've got my sequence numbers. And right here, the permit ICMP host is the limiting factor, right? That's what is controlling the pings right now. So let's go into IP access list extended PC4 permit. And I'm going to just remove number 20. So I'll say no 20. So now let's do a show access list. Okay, that looks good, right? Do you think it will work? I hope you said no, because I don't think it's going to work yet. Right, it's not working, and this should be able to ping now. Not working. Let's see if we can ping Why isn't it working? Well, the reason it isn't working is because we still have this deny IP any representing the implicit deny. So what we can do is go back into our access list. Okay. Now let's do a 20 permit any. Actually, let's just do ICMP any. Okay. Show access list. Voila. Now I think it will work because we are saying permit ICMP from any source to any destination. Yay, that one worked. How about this one? Yep, that one worked. All right. Now we have not changed anything to do with the web browser. So this one would still be able to get to the web browser. Let's check and make sure. Yep. And this one still should not be able to get to the web browser. All right, and this one still should not be able to get to the web browser, and it doesn't. So we're good. I hope this sheds some light on how to do extended access control lists, and I would like to recommend you just do a lot of practicing and get good at documenting everything. The better you are at this, the easier it is to write access control lists. Thanks for watching.